Okay, so I totally did the wrong thing just now. So, restarting. We're talking about normal calculations in reverse. So this is where instead of getting a real data point, like a quiz score and finding a percent, you start with a percent and you want to end up with a quiz score or any other regular real-world data point. So this is the same problem I've been using in class. I give a quiz in class with an average score of 60 and a standard deviation of 8. Those are important. These quiz scores are normally distributed, also important because you can't do any of this if they're not normal. What score do you have to be at the 60th percentile? Meaning, what quiz score do you have to be at the 60th percentile? Now, ignore those because I'll come back to them. We are starting now from, typically we started with a score and went that way to a percent. Well, not happening this time. We're starting with a percent and going that way. Now we have 60, we're the 60th percentile. If I was to draw that on a table, we are at a place where 60% or 0.6 area did worse than us. That's percentile means. We're above that 60%. Meaning, we're going to first, to do this, we're going to first use the table to change that into a z-score. How do we change a percent to a z-score? Well, that's not technically what we're doing. We're actually finding the z-score such that the area to the left of it is 60%. So we need to find the z-score first, and then that represents the quiz score we need, so then we have to change it into the quiz score with our little formula. X minus mean over standard deviation equals z. So, first we're going to use the table. I'm going to take 60%, change it to a z-score. This was from another problem. We're going to look at 60%. What I need to do, I'll make a table help video soon, but I'm looking for percent. Percent's in the middle, z-scores are on the outside. So I'm looking for 60%, somewhere over here. I'm seeing some 0.6s. Here we go. That and that look the closest. I think 0.5987 is a smidge closer. So that's the one we're going to use. So to find the z-score that goes with it, we go backward battleship. And you know, we're going reverse. If we're doing the other way, we do forward battleship. But now we start with the battleship. Go back. 0.25. Cool. So now I know if I can ever find the problem that we were in. Sweet. We have 0.25 is z. That we use the table to find a z-score from the first. So I know that missing z-score is 0.25. Now I need to use the formula to finish the job. Now that I have a z-score, I need to do my step 2 and take it back to the formula. So we do a little algebra. We plug in what we know. We have a z-score, we have a mean, and we have a standard deviation. So we have this, this, and this. We're just missing the x. So I plugged in my numbers, and we can ignore the algebra happening here because I'll redo it. Alright. So I plugged everything in. Now I just need to solve for that missing x with a little algebra. Not a lot of algebra in this class. This is the extent of it. So I'm going to multiply both sides by 8 to help wipe that 8 out because it was division. Then I end up with 8 times 0.25 is 2. So minus 60. So now I have to add 60 to both sides. And I end up with 62. 62 equals x. And that's my quiz score that I need to be at the 60th percentile. That means if I have a 62, I'm beating 60% of the class. Alright, hopefully this video actually recorded. Let's try it.